Hey everyone, my name is Mr. Pogemiller-Kermani.
I'm Chloe Kermani.
And I'm Mr. Kermani, and this is
Magic Milk!
So what we're going to do today is make milk magical. So what are we going to need, Chloe Kermani, to make the milk magical?
Well, today you're going to need some whole milk, but you could use 2% milk, soy milk, whatever you have. For this, you're also going to need some food coloring, but you could use pepper as an alternative. Any type of dish detergent will also do.
And
You'll need a plate.
that's right. And that's all you need. Go. Oh.
So what we're gonna need to do, Chloe, I'm gonna need you to first pour the milk into this bowl / plate we have.
So we're going to just fill it up there. Don't fill it up too high.
You fill up a little more.
Remember, this might get a little messy, so if you can do it outside or on a, flat surface like we have here. And now we're gonna need Chloe to put the food coloring in. Now it's really important you only put 1 drop in of each.
Yes, so I'm going to be using 4 colors. We're going to put 1 drop here.
That's fine.
And that's fine. If we get 1 or 2,
Yeah.
it's okay.
You can see it's sort of spreading out. Just put a drop. And we're going to just put 1 in each of the corners here. And last but not least, some yellow.
And finally, we're gonna put a little dish soap right in the middle. Here you go, Chloe.
So what it's just a little bit. You don't want to do any more than a drop. So just going to put a little drop right here. And as you see, all the colors just spread out.
And right now, we'll let Mr. PK explain why that happened.
So this is the science of magic milk. So why in the beginning of the experiment did the food dye stay on top of the milk? Well, this has to do with something called density, which is how many molecules and atoms are in a given amount of space. Low density matter has a small amount of molecules in a given space, and higher density matter has more molecules and atoms in a given amount of space. Now, the food dye is less dense than the milk, which means it has less molecules in a given amount of space compared to the milk. And when things are less dense, they float on top of more dense things. So here's an example of that with a density column, where lamp oil is the least dense and honey is the most dense liquid on the bottom. And these are arranged in a decreasing amount of density. Lamp oil is the least dense, honey is the most dense. Now, why did the magical milk happen? Why did the food dye swirl on the surface? Well, that's because of 2 things, surface tension and surfactants. So surface tension is this concept where molecules on the surface of a liquid are attracted towards the liquid down below it. So these pink arrows represent an attraction between molecules. So molecules on the surface are attracted towards the liquid down below and to each other side by side, and by doing so they are resistant to being broken to things above it. So this water strider is able to float on the surface because it is unable to break the surface because of this force of attraction between the liquid molecules. Now, in comes detergent, who wants to break the surface. So detergents are surfactants, which means that they are molecules that have a side that are attracted to water and a side that is repelled by water and attracted to fats. So it is attracted to water on one side, attracted to fats on the other side. And what does this have to do with milk? Well, milk has a watery part to it and a fatty part to it. And when you put the detergent into the milk, part of the milk that's water-based will be attracted to one part of the detergent, and the part of the milk that is fat-based will be attracted to the fat-loving side of the detergent. And when that happens, Wherever the detergent touches the milk, the surface tension is broken. It can no longer resist the detergent, and the surface of the milk is drawn to the edges that don't touch the detergent, that have not yet had their surface broken by the detergent. So when the detergent touches the milk, the food dye standing on top of the milk hitches a ride along with the surface of the milk, which is drawn to the edges where the milk surface was not broken. And that is how magic milk works. Thank you so much for joining us, and we hope you enjoy creating this experiment yourself.